Welcome to section 1.1, day 1, limits. Today's objective is to determine the value of limits algebraically and graphically, and determine the existence of limits using one-sided limits. So limits. Limits describe how the outputs of a function to behave as the inputs approach a particular value. So where's a function headed as we get closer and closer to some x value, whatever our variable is? So if you look at our picture here up on the upper right, you'll see we're getting closer and closer to 2 on the x-axis, and you'll notice that our y gets closer and closer to 4. We don't care what actually happens at 2, we just care what happens as we get closer and closer to 2 from both the left and the right sides. We can determine the limits two ways. We can do it algebraically or graphically like our picture. Doing limits algebraically. If you have a polynomial function and c is a real number, if you can plug the number in, you get your limit. And a lot of times we can do this, we just plug the number into our function and we get back a value which will be our limit. If we were given a rational function where we have one function divided by another function and we plug it in, as long as we do not make the denominator go to 0, we can find our limit. So basically, and there's other reasons why we can't do limits algebraically, but if we can plug c in for x without causing problems, we're not taking the square root of negative numbers, our denominators don't go to 0, we can calculate limits this way. Algebraically is usually pretty simple if it works. We're going to do both of these today. The first thing we are going to do today is do some algebraic limits. So here we have the limit as x approaches 0 of 2x cubed minus 3x squared plus x minus 1. All we have to do is plug 0 in for x and see what we get back. We're plugging in 0, so we have 2 times 0 cubed minus 3 times 0 squared plus 0 minus 1. And when we do this, we get negative 1. The limit as we approach 0 is negative 1. For the next one, we're going to plug in 1. We have the limit as x approaches 1 of x to the 4th minus x cubed plus 1 all over x squared plus 9. And again, we're just going to plug in. We have 1 to the 4th minus 1 cubed plus 1 over 1 squared plus 9. And when you simplify this out, you get 1 minus 1 plus 1 over 1 plus 9, which is just 1 over 10. So our limit for the second one is 1/10. All right, next we're going to look at things graphically. So limits done graphically. Determine limits using a calculator, graph the function. Look at the graph or the table to determine how the graph behave as you approach the specified x value. So in the first one, we have the limit as x approaches 0 of sine of 3x over x. I have already graphed this. This is for my graphing calculator. And if you look at the graph, I did use a scale of 1 on both the x and y axes. So our limit as we approach 0 is 3. Then we have the limit as x approaches 0 of x minus sine of x over x. Again, I graphed this. My scale is by 1s. And if you look at this one, as we go through 0, we're at 0. So the limit here is 0. As all you're going to do with these, you're going to graph them, see what happens. For the bottom left, we have the limit as x approaches 0 of 8 sine of x over sine of 3x. This one's a little hard to see on this, but if you graphed it on a calculator, you would see it's not quite up to 3. It's close. We would use a table, and you would find that this is approaching 2.667, or 2 2/3. And the last one we have is the limit as x approaches 1 of x squared minus 4 over x minus 1. Again, we plug this in. We're trying to see what happens at 1. This one's a little different, because if you put where 1 is, sometimes on your graphing calculators it's hard to see. There's a vertical asymptote right there. You might remember that from last year. There's a vertical asymptote there, so it never gets there. And when you look at this, the left side is going up to positive infinity. The bottom side is going to negative infinity. They are not approaching the same value. So this limit does not exist because both sides are not approaching the same value. One-sided limits. Sometimes it's necessary to determine limits from one side of a specified x value. And how we do this is our notation is limit as x approaches c, and it gives you an exponent of positive of f of x. And the way we read it, the limit of f of x as x approaches c from the right. from the positive side of the graph. That's why we have the plus sign. We're coming in from the right side. Then we also have the same thing for the left side. We use a negative sign though instead. And we have the limit of f of x as x approaches c from the left, because we're coming from the negative side of the graph. If the limit as we approach c from the right does not equal to c from the left, we do not have a limit. It does not exist. The limits from left and right must agree. They must go to the same value, or there is no limit. So remember the notation. We will be using that quite a bit. So here we have limit of f of x equals 2 from the right. So we're looking at this piece right here. Right here we're looking at this because we're coming in from the right. We hit this line, we go up to where 2 is, and 2 is going to 8. We're doing limit from as x approaches 2 from the left. So now we're using the other piece. So we're coming in from this side. We hit this line, or this curve, and we are approaching, as we get to 2, we are approaching 6. And if we were looking for the limit as x approaches 2 of f of x, since it's approaching 8 from the right and 6 from the left, this would be D and E. Does not exist. This is how we use one-sided limits. Let's do a few more. So here we have two graphs. We're going to do the ones on the left graph, ones on the right graph. So we have the limit as x approaches 2 from the right of f of x. So we're coming in from the right. We're on this line right here, and we get toward 2. We end up getting to negative 0.5. Then it says what happens when the limit as x approaches 2 from the left of f of x. So now we're coming along here. We're approaching from this line going up. And we are also getting to negative 0.5. So our limit, since they agree, is negative 0.5. Since we agree from the left and the right, we have a limit of negative 0.5. On the right graph, we have the limit as x approaches 0 from the left. So we're coming in on this line right here. And as we approach 0, we are at negative 4. Then we're going to do 0 from the right. So we're coming on this one on the top. And as we get to 0, we are approaching positive 4. And then we have the limit as x approaches 0 of f of x. Well, negative 4 and 4 are not the same number. Our left and right limits do not agree. So we have a do not exist condition. All right, that is the intro to limits. We'll do more with these in day 2. We'll be using one-sided limits to make sure that the limit from the left and the limit from the right, if they agree, we have a limit. If they are not the same, we do not have a limit, and it does not exist. So today's objective, we determined values of limits algebraically and graphically, and we used one-sided limits. Thank you for watching, and have a nice day.